Okay students, today we are going to discuss chapter 3, which is square and square root, and exercise 3.2, which are based on method to find the square root of any number. Okay, if the number is given in form of perfect square, we have to find the square root of that number. There are different methods are going to be applied to find the square root of any number which is perfect square. As first one is perfect square by repeated subtraction by successive odd number started from 1. Okay, as you know that one, suppose a perfect square number is given as 25. Okay, so we have to find the perfect square root of 25 by using a repeated subtraction method. Okay, which is going to start from 1, means the odd number is going to be subtracted, successive odd number. Okay, repeated subtraction by successive odd number started from 1. Look here, suppose the number is given here 25. So what they are given? The method is given that we have to subtract by repeated successive odd number. Okay, the first odd number which is started from 1. The first odd number is 1. So if we subtract 1 from 25, what we get? 24. Then 24 minus 3. What will get? 21. Then 21 minus 5. What will get? 16. And 16 minus 7. We get 9. And 9 minus 9. Finally, what will get? The 0. If we get the 0, it means there is no any number required or remain to subtract. Okay, so finally we get the 0 after how many steps? 1, 2, 3, 4 and 5. It means after completion of 5 successive subtraction, which is started from 1, we get 0. Finally we get 0. So you can write after subtracting how many? 1, 2, 3, 4, 5. So 5 successive odd number we obtain 0. So finally what you can write? So square root of 25. So in case of square root, we have to write like this: square root of 25 is equal to 5. Okay, so write this one and we'll discuss some other way or another method to find the square root of any perfect square. Okay, the second method is prime factorization method. As you know that one, 144 is a perfect square. Okay, you know that one, 144 is a perfect square. So we have to find the square root of 144. So what we have to do? By using the prime factorization method, we have to get the prime factor of 144. So it is going to try to divide the given number by the smallest prime number, which is 2. If it is possible, that number is going to be divisible by that number. So 2 7 ja 14 and 2 2 ja 4. Then 2 3 ja 6 and 2 6 are 12. 2 1 are 2, 2 8 are 16. 9. Then 3 3 are 9. Then what you get as 2 into 2 into 2 into 2 into 3 into 3. All are inside root. So we can write 144 as 2 into 2 into 2 into 2 into 3 into 3. All these numbers are prime numbers. So we can write, we have factorized 144 in the term of 2 into 2 into 2 into 3 into 3. So finally you can write like this inside the root, under root, 2 raised to the power 2. For this 2, it makes 3 blocks or 3 pairs. One is pair of 2, this one is also pair of 2, and finally this is pair of 3. So finally we can write like this, 2 to the power 2 and 3 to the power 3. Actually we omitting this sign of 2 here, but there is sign of this, there is 2 also for root. So if you want to write, you can. You want to leave that one, you can. This is not necessary to write. So finally what we'll get, if we remove the sign of root, then all the squares will be removed. That what we'll get, 2 into 2 into 3, which is 3 2 is 6, 6 2 is 12. So what we'll get, that 144 or 12. So you can finally write that one, square root of 144 is equal to what? 12. So by this method we can also find the square root of any perfect square. Write this one also. The third rule is by long division method. Suppose this number 5329 is 5329 is a perfect square. So we have to find the square root of 5329 by using long division method. To divide that one, 5329 or any number you want to divide that one by the long division method, make the group of 2 numbers from the left. Okay, so what we have to get, taken 2 number, group of 2 number from left. So what we have get here, 53, means we have to multiply a number by that number itself, which is equal to this number or near to this number. So we can say that one, 7 7 ja 49. So finally what we get, that 7 7 ja 49. Okay, 7 to 7 become 49. So if you subtract that one, we can't subtract 9 from 3, that's why we'll carry 1 from 5, it will be 13 minus 3 become 4. And look here, in general division, what we'll get, the one number is going to be carried from top, but here this is the block of 2 number or the pair of 2 numbers, so these 2 numbers will be came here. Okay, then again we repeat same number here, or someone there written the twice of that number. As you wish, 7 plus 7 become 14. Means we have to find a number by which is number going to be multiplied, which is equal to that number or near to that number. Suppose I have written 1. So 1 1 ja means 141 into 1, is it equal to this number? So in that cases, we have to find that one, guess that one, in which cases we'll get that one ones as 9. So finally we'll get that one. There is more probability to get the 3 3s are 9. So it will be 3. So let's check that one. We get the perfect square of 5329 or not? 3 3s are 9, 4 3s are 12, carried 1, and 3 1s are 3, and 1 4. So what, after subtracting that one, what will get? Remainder as 0. So you can write that one 73. It means it is 73 into 73, or 73 to the power 2, or only 73. So square root of is equal to 73. Okay, so write this one also. So now we are going to discuss question number 1, E of exercise 3.2, which is find the square root of the number by the prime factorization method. The number is given, this is the perfect square, therefore they are written find the square root of that number. So this number is perfect square, so we are required to find that number, the square root of it. Okay, so it means this number is equal to, this number is actually equal to or root under 363609. So by doing that one, the prime factorization method, we have to write 363609. First of all, what we discuss now, try to divide that one, the smallest prime number. The smallest prime number is 2. So 9 is the odd number, so this will be not divisible by 2. So we'll try to divide that one by 3. What will get? 3 1s are 3, 3 2s are 6, 3 1s are 3, 3 2s are 6, 0, and 3 3s are 9. Finally we'll get 3 plus 2 5 plus 1 6 plus 1 7 plus 2 9. So 9 is divisible by 3. So this number is also divisible by 3. So 3 4s are 12, 0, 3 4s are 12, 0, and 1. And what will be 4 plus 0 plus 4 plus 0 plus 1 become 9. So this number is also divisible by 3. 3 1s are 3, 3 3s are 9, 3 4s are 12, 3 6s are 18, and 3 7s are 21. Then 1 plus 3 4, 4 plus 4 8, 8 plus 6 14, 14 plus 7 21. So 21 is divisible by 3. So this number is also divisible by 3. So 3 4s are 12. So it become 14. So 3 4s are 12. So it become 26. 3 8s are 24. So it become 27. 3 9s are 27. So now the problem begin. So we have to see the number which divide or which can divide 4489. So the number should be prime. So as you know that one, the prime numbers are from 1 to 100 is as 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. So we have to check that one by one, but finally you get that one. This number is divisible by 67, which is 67 times. Then you will get this number is equal to 3 into 3 into 3 into 3 into 67 into 67. So we have to find the square of that number, means this is under root. So this is also in under root. So finally what we get? This is 3 square and 3 square and 67 square. Is it? Then after removing the root, we just get 3 into 3 into 67. Then 3 3 is 9, 67 into 9. Which is 603. So the perfect square root of that number is 603. Similarly, try to solve other given questions in exercise 3.1, question number 1. As I just solved E, so you solve A, B, C, D, E, I have solved that one. Then F, G, H, whatever given the number of questions, so try to solve that one. If there are any problem, you can ask me on my WhatsApp number, which is 8271706992. You can anytime you can ask this question. Okay.